Lesson 2.2, Solving Absolute Value Equations. Essential question, how can you solve an absolute value equation? Explore, solving absolute value equations graphically. So I'm saying there's going to be graphically and algebraically. There's a couple different ways to solve exponential or absolute value equations. So solving absolute value equations graphically. Absolute value equations differ from linear equations in that they may have two solutions. This is indicated with a disjunction, a mathematical statement created by connecting two other statements with the word or. To see why there can be two solutions, you can solve an absolute value equation using graphs. So A here, solve the equation 2 times the absolute value of x minus 5 minus 4 equals 2. Plot the function f of x equals 2 times the absolute value of x minus 5 minus 4 on the grid. Then plot the function g of x equals 2 as a horizontal line on the same grid and mark the points where the graphs intersect. So let's go to our calculator and we'll go to graphs. There it is. And so we got 2 times the absolute value, and we got x minus 5, and then go outside of that, minus 4. Let's graph that. All right, good. And it looks like that. Now, we'll press tab here, and we'll graph y equals 2, so we'll just put 2 there, enter, and then you'll notice that you have an intersection here and an intersection there, and let's see, we'll find those. Menu, 6, 4, and then we'll graph that. There it goes. Menu, 6, 4, and then we'll graph that, and then there you go. So there's your 2 points of intersection, 2, 2, and 8, 2. So let's go back to write the solution to this equation as an injunction or disjunction. That's going to be x equals 2 or x equals 8. And we can draw. Let's draw. Let's see, minus 5. So we're going to go over 5 and then down 4. 1, 2, 3, 4. That's going to be right there. And let's see. And let's see here. We'll grab it. And it's going to go through there. And it's going to go through about right there. So we'll put this here and that there. And we got to draw the other line, and we'll draw it in red. And this is the 2, y equals 2 line. And there's there. And the points of intersection are right here, and that's 2, 2, and this point right here, and that is 8, 2. All right. Reflect. Number 1. Why might you expect most absolute value equations to have 2 solutions? Why not 3 or 4? If the absolute value expression is not equal to 0, the expression inside an absolute value can be either positive or negative. So there can be at most 2 solutions. Well, how many legs you got here? You got 1 leg, 2 legs. So at most you can have is 2 solutions, looking at it graphically. and an absolute value graph can intersect a horizontal line at most two sides. So let's see here. Can have at most two solutions, like the one right there. Now it could have one, okay, and that might look something like this right here. So it could have one solution if it runs through, if it hits the vertex, can have at most two solutions, may have one solution. Is there another scenario where it might not have any? If it ran across here somewhere like that, it would have no solutions. See, it's no solutions. No solutions, and that's one solution. And the red one here is two solutions. So that will be the three. You can expect to get no solution, one solution, or two solutions, and never any more than that. Is it possible for an absolute value equation to have no solution, one solution? We just covered that. It is possible. If so, what would each look like graphically? And I just did that for you. Solving absolute value equations algebraically. To solve an absolute value equation algebraically, first isolate the absolute value expression on one side of the equation, the same way you would isolate a variable. Then use the rule. If the absolute value of x equals a, where a is a positive number, then x equals a or x equals negative a. Notice the use of a disjunction here in the rule for values of x. You cannot know from the original equation whether the expression inside the absolute value bars is positive or negative. So you must work through both sides, through both possibilities, to finish isolating x. So take a look at A and follow along, and then when you get back, we'll do B together. So let's take a look at B. So we have 3 times the absolute value of 4x minus 5 minus 2 equals 19. So we're going to first we're going to add 2 to both sides. So we get 3 times the absolute value of x, 4x minus 5 equals 21. Then we're going to divide both sides by 3, and we get the absolute value of 4x minus 5 equals 7. Now we're going to do, and we'll call this case 1 or case 2. Remember, the absolute value looks something like this right here, and you're talking about, this is read, the distance between 4x minus 5, the distance between 4x minus 5 and 0 is 7 units. Okay, so here's 0, so it's going to be over here somewhere, and it's going to be over there somewhere, and we don't know exactly where yet. So we're going to have 4x minus 5 equals 7, and 4x minus 5 equals negative 7. Add 5 to both sides, and that's going to give you 4x equals 12. Add 5 to both sides, and that will give you negative 2. Divide both sides by 4, that's going to give you x equals 3. Here we'll divide it by 4, and we get negative 1/2. Okay, so let's find 3. It's right here. And we got negative 1/2 is right there. So the distance between 4 times some point x minus 5 and 7, or the distance between 4x minus 5 and 0 is right. Anyway, here you go. It's right here. That's kind of, I need to stay away from that. That's kind of confusing. All right, your turn. Solve each absolute value equation algebraically. Graph the solution on a number line. So let's take a look at 3 here. Well, we got 1/2 times the absolute value of x plus 2 equals 10. So let's multiply both sides by 2. Multiply that by 2 and that by 2. And you get the absolute value of x plus 2 equals 20. All right, so case 1 is going to be x plus 2 equals 20. And then case 2 is going to be x plus 2 equals negative 20. All right, subtract 2 from both sides, and you got x equals 18. And subtract 2 from both sides, and you got x equals negative 22. So let's find negative 22 and 18. Well, 60, that's 20 right there. That's 20. Let's put it right here. And there's 20. So there's your solutions. What about this one here? Well, let's see. Subtract 5 from both sides, and you got negative 2 times the absolute value of x minus 6 equals negative 4. Divide by negative 2. Divide by negative 2. Absolute value of 3x minus 6 equals 2. So case 1, 3x minus 6 equals 2. Case 2, 3x minus 6 equals negative 2. We're going to add 6 to both sides. That's 3x equals 8. Add 6. That's going to be 3x equals 4. Divide by 3. And you got x equals 8 thirds. And x equals 4 thirds. 8 thirds, that's going to be, well, 9 thirds would be 3, would be 9 thirds. So 8 thirds is going to be a bit less than that. And 4 thirds, that's going to be 1 and 1/3. So that's 2 thirds. We'll say this is 4 thirds right here. Okay. All right. And there we go. Explain 2. Absolute value equations with fewer than 2 solutions. You have seen that absolute value equations can have 2 solutions when the isolated absolute value expression is equal to a positive number. When the absolute value is equal to 0, there is a single solution because 0 is its own opposite. When the absolute value expression is equal to a negative number, there is no solution because absolute value is never negative. And I showed you that a minute ago down below. Isolate the absolute value expression in each equation to determine if the equation can be solved. If so, finish the solution. If not, write no solution. So we'll let you follow through with A, and when you get back, we'll do B. All right, so B, we're going to start off by adding 3 to both sides. Plus 3, plus 3. So that's going to be 3/5 times the absolute value of 2x minus 4 equals 0. And then we're going to multiply both sides by 5 thirds times 5 thirds. And that's going to give us 2x minus 4. The absolute value of 2x minus 4 equals 0. Then, well, think about it. If we did case A, case 1, that would be 2x minus 4 equals 0. Case 2 would be 2x minus 4 equals, well, what's the opposite of 0? Look on the number line. Look on the number line. What do we got here? Here's your number line. And then, all right, so you got 0 here. Well, 1, its opposite is negative 1, right? 2 has an opposite of negative 2. 0 is its own opposite, so we don't have to do it. Add 4 to both sides. You got 2x. 2x minus 4 equals 0. add 4 to both sides, so 2x equals 4. Divide both sides by 2, and you got x equals 2. So there's one solution. And what that would look like graphically, that would look like, and I'm just going to draw one. It's not necessarily this one right here. I'm just going to draw one. We'll put it right there. And the line would just, you're looking at one where the line goes through the vertex like that. Okay? So 5. Well, you know something? Let's go ahead and we're gonna graph that on the calculator just to show you. That way we get it just right. New document, no, graph, and then let's see, control, divide, and I got 3 over 5 times, and then we got the absolute value, and we've got 2x minus 4, 2x minus 4, minus 3. Press enter, and there it is. And then let's just, we'll do one, press y equals -3. And then see how it goes through the vertex. All right. My graph wasn't all that far off, was it? Isolate the absolute value expression in each equation to determine if the equation can be solved. If so, finish the solution. If not, write no solution. So let's take this first one here. Let's subtract 7 from both sides. And we got 3 times the absolute value of 1/2 x plus 5 equals -2. Well, let's go ahead and divide both sides by 3. And we got the absolute value of 1/2 x plus 5 equals -2/3. Okay, now see, we got the absolute value isolated, and so it can't equal a negative, so we're going to write no solution. All right, no solution. Now let's look over here. Let's subtract 7 from both sides. And we got 9 times the absolute value of 4/3 x minus 2 equals 0. We can divide both sides by 9. And we got the absolute value of 4/3 x minus 2 equals 0. So we just got one case here. 4/3 x minus 2 equals 0. Add 2 to both sides. You got 4/3 x equals 2. And to get rid of this 4/3, we're going to multiply it by 3/4. It's reciprocal times 3/4. And that's going to give us x equals, and then see, that's a 1 and that's a 2. So I'm getting 3/2. I'm getting 3/2. Good deal. Good deal. 7. Elaborate. Why is it important to solve both equations in the disjunction arising from an absolute value equation? The solution to a mathematical equation is not simply any value of the variable that makes the equation true. So why not just pick one and solve it, knowing the solution for the variable will work when plugged back in the equation? Well, supplying only one value that works in the equation implies that it is the only value that works, which is incorrect. So we'll say, let's write this out. The solution to a mathematical is in $25 words. Equation is not simply any value of the variable that makes the equation equation true. Supplying only one value that works in the equation implies that it is the only value that works. Which is incorrect. Eight, discuss how the range of the absolute value function differs from the range of a linear function. Graphically, how does this explain why a linear equation always has exactly one solution, while an absolute value equation can have one, two, or no solutions? Well, let's look. Maybe let's draw a little graph here. And we're going to draw a linear equation. Okay. And for a linear equation, we'll do something like this right here. There's a linear equation. And all right, now let's draw an absolute value equation. And I didn't want to use black. Let's use green. And again, let's try to use green. There's green. And we'll say all right, there's our absolute value equation. Now, how are these different? Well, the linear equation, it's a line, isn't it? It's got arrows on both ends, and it goes, and it could go like this or whatnot, but it goes in that direction forever, and it goes in that direction. Look at the absolute value. How is that different? Well, you got this vertex here where it changes direction. It changes direction. And that makes all the difference in the world. The range of a non-constant linear function is all real numbers. The range of an absolute value function is y is greater than or equal to k if the function opens upward, and y is less than or equal to k if the function opens downward. Because the graph of a linear function is a line, a horizontal line will intersect it only once. Because the graph of an absolute value function is a V, or horizontal line can intersect it once, twice, or not at all. So if you were to draw a horizontal line on this, you could only intersect, if you drew here or here, no matter where you draw it, you're only going to intersect it one time. Where you come over here to the absolute value, look, you can, if you do it up here, you're going to intersect it twice. If you do it right through the vertex, you're going to intersect it once. Or if you do it down here, you're not going to intersect it at all. And we'll just see, you can, there's twice. That one there is just once, and then down here is none at all. Okay, so the range of a non-constant linear function well, I'm not doing well on my ends at all, is all real numbers. Is all real numbers. Okay? The range of an absolute value function is y is greater than or equal to k if the function opens upward or y less than or equal to k if the function opens downward. Because the graph of a linear function is a line a horizontal line will intersect it only once. Because the graph of an absolute value function is a V, or it could be like that, either way, upside down V, or horizontal line can intersect it once, twice, or not at all. All right. Essential question check-in. Describe in your own words the basic steps to solving absolute value equations and how many solutions to expect. Well, the big thing is to isolate the absolute value expression the big thing is to isolate the absolute value expression. So if you had something like, let's see, 3 times the absolute value of x plus 4 minus 2 equals 7, what you're going to want to do is you're going to want to isolate this part here by itself and everything else on the right-hand side. You'll want this over to the right, you'll want that over to the right, and of course that'll stay over to the right. You want to isolate that. If the absolute value expression is equal to a positive number, solve for both the positive and negative case. If the absolute value expression is equal to 0, equal to 0, then remove the absolute value bars and solve the equation. There is one solution. If it equals 0, there's going to be one solution. If the absolute value expression is equal to a negative number, then there is no solution. All right, folks, great job. See you tomorrow in class and have a nice evening.